The aviation authorities grounded it. The passengers feared it. The headlines condemned it. Airlines pulled it from their most visible routes to avoid the association. For a period in the late 1970s, the DC-10 was the aircraft that no one wanted to admit they were boarding. And then something unexpected happened. The industry looked at everything it needed an aircraft to do: the range, the capacity, the ability to carry heavy loads over long distances from airports that smaller aircraft couldn't serve. And it reached, quietly and with minimal ceremony, for the DC-10, again and again and again. The aircraft that replaced the DC-10 was called the MD-11. It was in almost every essential respect a DC-10. The aircraft that replaced many MD-11s in freight service was, in a number of cases, the DC-10 itself, still airworthy, still useful, still doing work that newer aircraft couldn't do as economically. The question isn't why the DC-10 was controversial. The question is why it refused to go away. The answer is more interesting than the controversy. To understand the DC-10, what it was, what it became, and why it keeps showing up no matter how many times the industry tries to move past it, you have to understand the specific commercial problem it was designed to solve and why that problem proved more durable than the controversies that surrounded the aircraft's early years. The late 1960s were a moment of enormous ambition in commercial aviation. The Boeing 747 was in development, promising to carry nearly 500 passengers, a number so large that airports were scrambling to build terminals capable of handling the flows of people it would produce. The 747 was going to change everything. It was going to make long-haul travel cheaper, more accessible, and more efficient than anything that had come before it. But the 747 was a solution to a specific problem: the high-density, high-volume long-haul route where filling 500 seats was genuinely achievable. On routes that were long enough to need a wide-body aircraft but not quite busy enough to fill a 747, it was a commercial mismatch. You were either operating a too small narrow-body aircraft and leaving capacity on the table, or you were operating a 747 at load factors that made the economics painful. American Airlines identified this problem with characteristic commercial precision and went to the manufacturers with a specific brief. They needed a wide-body aircraft smaller than the 747, capable of operating from airports and runways that couldn't handle the 747's weight and size, with the range and payload to serve the routes where the 747 was too much and the narrow bodies were too little. Douglas, still operating as a standalone company before the merger with McDonnell that would eventually produce McDonnell Douglas, responded with the DC-10. Lockheed responded with the L-1011 TriStar. Both aircraft were wide-body trijets, 3 engines, twin aisles, capacity in the 200 to 350 passenger range depending on configuration. Both were serious attempts to answer a real commercial question, and both would become entangled in controversies that their engineering in itself did nothing to produce. The DC-10 that Douglas built was, as an engineering object, genuinely impressive. It was large without being unmanageable. It had the range to serve transatlantic routes, but the field performance to operate from airports that the 747 couldn't use. It had a cargo capacity that made it commercially attractive not just for passenger service, but for freight, a market that would eventually become the DC-10's most durable home. And it had 3 engines in an arrangement that was, in one specific design choice, the source of everything that went wrong afterward. 2 engines under the wings, 1 engine in the tail. The tail engine required a specific structural arrangement, a cutout in the vertical stabilizer, through which the engine's inlet drew air that was unique to this class of aircraft and that created, in combination with a cargo door design decision that would prove catastrophic, the conditions for the accidents that would define the DC-10's public reputation for a generation. By the way, if you like stories like this, subscribing takes 2 seconds, and there's a lot more coming. The DC-10 was different from what came before in ways that passengers noticed immediately and in ways that only became apparent over time, and the 2 categories of difference point in entirely different directions. What passengers noticed first was the space.
The DC-10's twin-aisle interior was genuinely wide enough that the middle section of the cabin, which on most aircraft is the least desirable real estate, felt habitable rather than merely tolerable. The aircraft was configured to carry passengers in real comfort at a price point that, by the standards of the early wide-body era, was accessible to a broader range of travelers than the 747's premium positioning allowed. Airlines that operated the DC-10 could fill it at economics that worked, and passengers who flew on it regularly came to appreciate its combination of space and efficiency. The flight deck was modern by the standards of its era, a three-crew cockpit with systems arranged with the logic of an aircraft designed in the late 1960s, incorporating lessons from a generation of jet transport operation. Pilots who transitioned to the DC-10 from earlier types found it demanding in the ways that all wide-body jets were demanding, but not exceptionally so. The aircraft flew with a solidity appropriate to its size, a planted quality that large aircraft often have, the feeling of something with enough momentum to smooth out the small imperfections that smaller aircraft communicate more directly. The cargo capacity was a dimension of the DC-10 that proved more significant to its long-term story than anyone in the marketing department fully anticipated at the time of its introduction. The DC-10 could carry substantial freight payloads alongside its passengers, and the relationship between its passenger deck economics and its cargo revenue made it commercially attractive on routes where the combination of revenue streams worked in ways that pure passenger economics didn't always achieve alone. But the cargo capacity also introduced a design decision that would produce the DC-10's most damaging early chapter: the rear cargo door. Unlike most aircraft cargo doors of the era, which opened inward, meaning that pressurization forces worked to keep them sealed, the DC-10's rear cargo door was designed to open outward. This made loading easier and faster. It also meant that the door's latching mechanism was the only thing standing between a sealed aircraft and catastrophic rapid decompression if it failed. The latching mechanism had a design flaw. The flaw was identified. A fix was recommended. The fix was not implemented with the urgency the situation demanded. And in 1974, over a forest outside Paris, the rear cargo door of a Turkish Airlines DC-10 opened in flight. The resulting decompression caused the cabin floor to collapse. The collapsed floor severed the control cables that ran beneath it. The aircraft, with 346 people aboard, became uncontrollable and struck the ground 9 minutes after takeoff. It was the deadliest aviation accident in history at the time, and it happened on an aircraft that had been warned by its own engineers that this specific failure mode was possible. The door was fixed, fleet-wide, urgently, in the way that it should have happened years earlier. But the damage to the DC-10's reputation was not fixable in the same way. The public had learned that the aircraft had a known flaw, that the flaw had killed hundreds of people, and that the fix had been delayed. That knowledge settled into the cultural memory of the aircraft in a way that technical remediation could not fully address. 5 years later, the DC-10's reputation encountered another catastrophe that it was even less able to survive. An American Airlines DC-10 departing Chicago O'Hare lost an engine during takeoff. Not an inherently survivable event in a 3-engine aircraft, but the engine separation had damaged the hydraulic systems that controlled the slats on the left wing. Without those slats, the left wing's lift characteristics changed dramatically from the right wing's. The aircraft rolled left, reached an angle from which recovery was impossible, and crashed seconds after liftoff. 273 people died. The FAA grounded every DC-10 in the United States. It was the first time a specific aircraft type had been grounded in America since the Comet disasters, and the parallels were not lost on anyone. The grounding lasted 37 days. When the aircraft returned to service, the technical causes had been addressed, but the public's relationship with the DC-10 had changed in ways that no maintenance bulletin could reverse.
The human experience of the DC-10 era is a story told from two completely different positions that rarely communicated with each other, and the gap between them is one of the most revealing fault lines in commercial aviation history. For the pilots and flight crews who flew the DC-10 professionally, the aircraft was a capable, if demanding, wide-body jet that had specific technical issues. Those issues had been addressed, and the aircraft that remained in service after the fixes were implemented was not the aircraft that had produced the accidents. Pilots describe the DC-10 with the professional directness of people whose assessment of an aircraft is based on what it actually does in their hands rather than what the newspapers say about it. It flew.
It was responsive for its size. The systems were manageable for crews who knew them well. The accidents, as pilots understood them, were the result of specific, identifiable, correctable problems, not evidence of a fundamentally flawed machine. The flight attendants occupied a more complicated position. They were the human face of the aircraft for the passengers who were, by the late 1970s, actively expressing concern about boarding DC-10s. Some passengers refused. Some demanded seat changes, believing without any aerodynamic basis that certain seats were safer than others on an aircraft they had already decided they didn't trust. The flight attendants managed these interactions with the professional composure their training demanded, providing reassurance that was honest, the aircraft was safe, the problems had been fixed, but that some passengers were not able to receive in the emotional state the news coverage had produced. The mechanics who maintained the DC-10 in the post-grounding period described the heightened scrutiny that was, in retrospect, probably appropriate. The grounding had revealed that maintenance practices around the DC-10 engine pylon attachment, the way the engines were removed and reinstalled during maintenance, had in some cases introduced damage that inspection procedures had not caught. The post-grounding maintenance protocols were significantly more rigorous. The mechanics who implemented them did so with the specific awareness that they were working on an aircraft whose public trust had been spent, and that rebuilding it required a standard of work that left nothing to assumption. And then there were the passengers who simply refused, who booked on 747s or L-1011s or narrow-body aircraft rather than accept the DC-10 ticket regardless of what the safety record said after the repairs. Their fear was not irrational. It was a reasonable response to specific, documented, recent events. But it was fear that the aircraft's subsequent record would not vindicate. The DC-10, after the cargo door fix and after the revised engine pylon maintenance procedures, accumulated a safety record that was consistent with its contemporaries. The passengers who avoided it were avoiding a risk that had been substantially reduced. But fear, once established by events as dramatic as the ones the DC-10 had produced, does not respond readily to subsequent data. By the way, if you like stories like this, subscribing takes 2 seconds, and there's a lot more coming. The conflict at the heart of the DC-10 story is the conflict between reputation and utility. And utility, in this case, won in the most comprehensive way possible. Airlines pulled the DC-10 from their most visible routes after the Chicago accident. Passengers had made their feelings clear through booking patterns that no airline could afford to ignore. But the aircraft didn't disappear. It couldn't disappear, because the commercial problem it had been designed to solve was still real. The aircraft still solved it, and the economics of simply retiring functioning airframes were not supportable. So the DC-10 went to work in less visible places, in freight operations, where the cargo it carried had no opinion about what aircraft transported it. In military service, where the KC-10 extender tanker variant proved so effective at aerial refueling that the Air Force couldn't afford to care what the public thought of the civilian model. On routes where the combination of range and payload made it the most economically sensible choice regardless of its reputation. McDonnell Douglas responded to the DC-10's reputational damage by developing the MD-11, a stretched, modernized variant with updated systems, a 2-crew glass cockpit replacing the original 3-crew analog flight deck, and aerodynamic refinements that improved fuel economy. The MD-11 was marketed as a new aircraft. It was. In its fundamental architecture, its 3-engine configuration, its basic airframe proportions, and its operational envelope, recognizably the same machine that had been grounded in 1979. The MD-11 had its own difficulties. Its fuel burn in service proved higher than McDonnell Douglas had projected, which created problems for airlines whose business cases had been built on the manufacturer's numbers. Several operators returned aircraft or renegotiated contracts. The passenger MD-11 market contracted faster than McDonnell Douglas had hoped, and the type found its most stable home in freight operations, exactly as the DC-10 had before it. The merger of McDonnell Douglas with Boeing in 1997 ended any prospect of further DC-10 or MD-11 derivatives. Boeing had no commercial interest in developing a product line that competed with its own 777, and the DC-10 family's passenger service days were effectively concluded by the terms of a corporate transaction rather than by any failure of the aircraft itself.
The DC-10's legacy is the legacy of utility so genuine and so durable that it survived everything the aircraft's history threw at it.
In 2026, DC-10 freighters are still operating. MD-11 freighters are still operating. The KC-10 extender tankers that the U.S. Air Force operates are still flying missions, still extending the reach of American air power, still performing the role for which they were adapted from an aircraft that was grounded for 37 days in 1979 because of public fear. The DC-10 teaches something that the aviation industry has had to learn repeatedly, in different contexts and with different aircraft. The gap between public perception of an aircraft and its operational reality can be enormous. And the forces that shape public perception, dramatic accidents, vivid headlines, the specific anxiety of putting your life in the hands of a machine you don't control, are not the same forces that shape operational reality. The DC-10 had genuine problems. Those problems were real, were consequential, and were addressed inadequately and too slowly in ways that cost lives. That part of the story is not diminished by the subsequent safety record. The subsequent safety record is also real. Both things are true simultaneously, and the DC-10's legacy requires holding both of them at once, rather than choosing the version that suits the narrative you prefer. The aircraft that was designed to fill the gap between the 747 and the narrow-bodies is still filling gaps in freight networks, in military operations, in the corners of the global aviation system where its specific combination of capabilities remains unmatched by anything built to replace it. The DC-10 was supposed to be replaced. Its replacement was another DC-10. That replacement is still flying, and the original is still flying. We began with a question. How does an aircraft that was grounded, feared, and condemned by the public manage to keep showing up in new forms, under new names, doing the same work for half a century? The answer is simpler than the controversy surrounding the DC-10 might suggest. The aircraft worked. It carried people and cargo over distances and from airports that other aircraft couldn't serve as efficiently. It did this before the accidents, and it did it after the fixes. And it did it in freight liveries after the passengers stopped trusting it. And it did it in military tanker variants after the commercial passenger market moved on. It kept doing it because the problem it solved didn't go away, and because no subsequent aircraft solved that problem more completely. The DC-10 is not a story about a perfect aircraft. It is a story about what happens when genuine utility meets public fear. And utility, given enough time and distance from the events that produced the fear, proves the more durable of the two. The aircraft taking off from that nighttime ramp is not celebrated. It is not photographed by enthusiasts the way the Constellation was photographed, or described with the language of love that pilots use for the great, beautiful aircraft of their careers. It is loaded and fueled and taxied and departed by people doing a job that requires a reliable machine. The DC-10 is that machine. It has always been that machine. And the industry, which tried more than once to replace it, has never fully managed to, which is, in its own quiet way, the highest possible compliment. By the way, if you like stories like this, subscribing takes 2 seconds, and there's a lot more coming.